are not fractions.
They're not fractions. They're meant to look like fractions.
So I'm supposed to conceptualize them as just numbers.
They are numbers.
So
but the point of writing it like a fraction is to make you realize it is a rate of change. It is the change of y.
Oh, okay.
That's
That
a
makes
delta
much more sense.
d, right? Change in y over change in x. That's what I was trying to compare to over here. They're using d's instead of deltas because although delta y is some solid finite quantity, the dy is an infinitesimally small thing.
So dy is representative of, in this case, it would be EU, right?
That's right.
And then this is EU over du, u representative of negative 4x squared.
Yeah, basically. It's how those things are changing.
And wouldn't those two cancel out though?
They don't cancel out because it's not really a fraction. But it's meant to convey that type of idea. That's what it's meant to do. So over here you can have y equals x squared. You would say y is a function of x, right? You could also write y equals, and you can put something inside here, like 3x plus 2 and square it, right? So now y, you could say is a function of x. You could say something more general. You could say y is a function of 3x plus 2, right? Because that's what's in, because y is the squaring function, right? If y is the squaring function, then right now when I write this, y is a function of 3x plus 2.
Okay, so the rate of change of dy over du is e to the u, right?
Yeah.
And then dy over dx is
The u over dx. Du dx.
u over dx. And du is represented by negative 4x squared.
U is, yeah, u is
And
negative.
then you take the derivative of that, which is negative px.
That's right.
Oh, it's representative of the derivative.
These, yeah, absolutely. Each one is derivative.
So that's an annotation for finding the derivative of the given. Like that's telling you to find the derivative of a certain thing.
Yeah, that's right. $11. You got it.
11?
Oh, what was wrong with 10? You said 10 was right but wrong.
Never mind.
Because it's the second derivative. That's why.
Yeah.
The second derivative.
I forgot to look at that.
All right. Number 11. You're okay or no?
No.
Okay. Equation tangent
Because I
line.
tried looking at the example and I don't even understand it.
Just take the derivative, plug in a number, and then find the tangent line. It's that same problem we've been doing.
Oh, well, I tried doing the derivative, but
Okay.
I get stuck in a part of the derivative.
What was your expression? Similar to this probably, but
It's x cubed on the top over x squared minus 6 to the power of 4.
okay.
And it's at 0.2 and 1/2. So it's the same thing.
2 and 1/2.
Right, it's the same point right there. 2 comma 1/2.
Okay.
Okay. So then you take the derivative of everything. So it'd be x squared minus 6 power 4 times the derivative of x to the third
Yeah.
minus x to the third times the derivative of the bottom term.
Okay. So what is that derivative? You would need to bring down the 4, right?
Oh,
That's the other part's fairly straightforward. So this is the last part.
yeah,
there.
so it's 4 and then x squared minus 6 to the power of 3
Times.
times what?
Times 2. You got chain rule here. Times 2x.
Times
You gotta take the derivative of the inner function, right? There's an inner function. X squared minus 6 is inside the fourth power function. So the 4 comes down. Here's your 3. Keep the inner function the same, and now multiply by the derivative inner function. Multiply by 2x there.
That's the derivative of the bottom part?
Yeah, if all you had was x squared minus 6 to the fourth, and you want to take that derivative, right? So then the 4 comes, so we're saying 4 comes down.
Yeah.
There is an inner function. X squared minus 6 is inside, right? So it's a composition. X squared minus 6 to the third, and you got to multiply by the derivative of this. So in this case, 2x. So that's why.
But then when you continue to simplify the numerator.
Oh, a second. Yeah. So then we also have this down here, right? X squared minus 6 to the 8th, right?
Where are you?
Just finishing up the quotient rule. x squared minus 6 to the 8 on the
Yeah.
bottom. Okay? So you said go ahead and simplify the numerator. Okay? So what you should note here is that every term above and below has an x squared minus 6 to some power. And so you should remove those. So the highest power they all have is 3, right? So we could rewrite this. For this one, the x squared minus 6 to the third will be completely gone from this one, right? Okay. And then this will leave one of them, and this will leave 5 of them. So we'll have x squared minus 6 to the first times 3x squared minus, I'm going to write this in better order, right? This is 8x to the fourth. 8x to the fourth. Okay? Bottom has the 5th power of that. Is that okay?
8x to the 4th. Okay, because you multiplied that. Okay, see, I couldn't get to that step.
Now we can continue this a little bit, because we see here that the 3x squared and the x squared will make a 4th power. We already have a 4th power, so we'll be able to combine this together. So we have 3x to the 4th minus 8x to the 4th would leave you negative 5x to the 4th, and you also have the negative 18x squared over the x squared minus 6 to the 5th.
How would you simplify that?
How would you simplify this?
The second part.
This one?
Yeah, how'd you go from the top?
I just multiplied. Oh, how did I get from here to here?
Yeah.
Because they all had the x squared minus 6 to a power.
Yeah, they all had it to the 3rd power. So I removed the 3rd power of x squared minus 6 from each term. So from this one, it's not going to be there at all, and I just have the 8x to the 4th still left. Over here, I'll have a single x squared minus 6 left, because it was to the 4th, and I'm taking out 3 of them, so I have 1 of them left and 3x squared sitting there. And this one has 5 left.
So that's going to be the slope.
That's the slope of that function anywhere you want. And we wanted it 2 1/2, so we'll plug in the 2 and find out the slope now. Right?
This is the chain rule?
No, just doing a homework problem.
Okay.
It could refactor the x squared at this point, but it doesn't really serve my purpose since we're just going to plug in 2, and that's all you really care about this thing for is plugging in 2.
Would you in the 8x to the 4th?
Where did I get the 8x to the 4th? 8 x to the 4th.
Oh.
So you plug in 2 now. 2 to the 4th is 16. 16 times 5 is 80.
Negative 80.
So you have negative 80 minus 2 squared is 4. 4 times 18 is 72. So minus 72. And at the bottom you have 4 minus 6, which is negative 2. 82 to the 5th is negative 42. Those are numbers. They do have a common factor. So, but we'll just go ahead and subtract first. Negative 152 over negative 32. So it's 152 over 32. And they both have 2's. So remove the 2's, you get a 76 over 16. They have 2's